All right, guys, in this video, I'm going to show you how to do page 1 of the Unit 2 study guide. So problem number 1 here and problem number 2 are to solve by factoring. So first things first is not set equal to 0. So let's go ahead and subtract 2 from both sides. So 3p squared minus 5p minus 2 equals 0. Pick your favorite factoring method. You guys hopefully know by now that guess and check is mine. So that's going to be a -6 plus 1. Looks good to me. So that's going to then set each factor equal to 0. All right, and we're going to get a p-value here of -1/3, and p equals here +2. So there's our two answers for problem number 1. I'm going to go ahead and slide on over to number 2 here. Same kind of problem. We are still supposed to be solving by factoring. It's still not set equal to 0, so let's make it be equal to 0. No like terms here. I'm going to write this in standard form, equal to 0. Again, factoring in this case is a little simpler. Since x squared is just x squared, there's no number in front. Let's see, 7 here, 4 here, make that negative, make that positive. That all works. So x minus 7 equals 0, x plus 4 equals 0. So I'm going to say x equals 7. Whoops, I'm not sure why I'm writing a double equal sign there. X equals 7 and -4. All right, so there's the first two problems. You need to know how to factor, okay? So make sure you're comfortable with that. Next set of questions, solve each equation by completing the square. So in this case, for problem number 3 here, whoops, try that again. This x squared being by itself is nice, so we're going to leave x squared minus 4x on one side. I'm going to move the 47 to the other side. So let's see, if I add 47, that's going to turn into 45 here. All right. I need to complete the square here. So I'm going to do half of the b value. So -4 chopped in half is -2. Square that gets me a +4. And I'm going to add 4 to both sides. So the left side can be factored as x minus 2 squared. The right side here turns into 49. All right, so that's completing the square. Now to solve it, we're going to actually square root and square root. So square and square root go away, as they should eliminate each other. We put the square root in the problem, so it's going to be plus or minus square root of 49 is 7. I'm going to add 2 to both sides, so x equals 2 plus or minus 7, which is going to give me an actual x value of, let's see, 2 plus 7 makes 9, 2 minus 7 makes -5. So there's my two answers for problem number 3. All right, kind of straightforward once you get past the setting up the completing the square piece. All right, problem number 4 here is a little bit more complicated because we're dealing with the 7 here. So the first thing I'm going to do is I'm going to subtract 8 from both sides. So 7x squared plus 14x, I'm going to subtract that 8. I feel like that's a -5. Yeah, sounds good. Now, in order to complete the square, I need to get rid of this 7 first. So let's go ahead and divide every single thing by 7. So x squared plus 2x, and leave that blank spot. And unfortunately, we're going to leave that fraction as well. So to fill in the blank spot, I am going to add 1. Half of 2 is 1. 1 squared is 1. Add 1 to the other side. So x plus 1 squared equals, conveniently off to the side here, I have a calculator on my table that I'm working on. So let's go ahead and do -5/7 plus 1. And I'm going to get 2/7 here. I'm going to take the square root of both sides. Square and square root eliminate each other as they should. We've got a plus minus here. Now, we're going to do the square root of 2/7. But actually off to the side here, I'm going to rationalize that. So the square root of 2/7 multiplied by root 7 over root 7. So that's going to turn into square root of 14 over just 7. All right. So in my next step, when I subtract 1 from both sides, I'm going to say that x equals -1 plus or minus. And instead of putting this square root of 2/7, I'm going to pull in the rationalized version. So square root of 14/7. And there's my answer for completing the square on number 4. So another way to solve that you will be expected to know how to do is completing the square here. So there's question 3 and 4. Okay. All right, I think the last 2 questions on this page are the absolute value inequalities. So we're going to solve it, we're going to graph it, and we're going to write the answer in interval notation. For both of these, before I do any kind of split, because I am going to need to split the inequalities, I'm going to isolate the absolute value first. So problem number 5 here, I'm going to divide both sides by 7. So the absolute value of x minus 1 is less than 5. Now I'm going to split it. So the first split's the easy one. Whoops, trying to put an equals to sign. There's not supposed to be one. So x minus 1 is less than 5. So this was less than. So this is going to be an and. X minus 1 is greater than negative 5. All right, solve both of these. We're going to add 1 to everything. So x is less than 6. And x is greater than, if I add 1, that's going to be negative 4. All right, so I've solved it. That part's done. Graph it. Only 2 things that I care about in this number line are the negative 4 here, positive 6 here. If x is less than 6, let me grab my shading here. I'm going to do yellow and blue make green. So x is less than 6, so from 6, I'm going to shade less than that. And then from x is greater than negative 4, I'm going to start at negative 4 and shade to the right. So this set right here, this overlap, is what I'm looking for. And in both cases, we've got parentheses. There's no equal to components. So parentheses negative 4 to 6. And if you want to see that, you can put those into the actual number line itself. So number 5 is done. We solved it, we graphed it, and we wrote the answer in interval notation. Okay, last problem on this page, problem number 6. So I am going to add 4 to both sides. All right, so absolute value of negative 6k minus 8 is greater than or equal to, I feel like 46 there. Sounds good. All right, split the absolute value. The first one's the easy one. Change nothing except you're dropping the absolute value bars. Okay, so negative 6k minus 8 greater than or equal to 46. Now it's greater than, so there's the or. Now the other inequality is going to be the exact same expression, but this time we're going to make it less than or equal to negative 46. All right, so we're going to add 8 to everything. So negative 6k is greater than or equal to, let's see, 46 plus 8 makes 54. Negative 6k less than or equal to negative 46. What did I say? I'm adding 8 to both sides, so negative 38. These are some fun numbers to play with. All right, dividing everything by, now be careful here. You are dividing by a negative. All right. And because you're dividing by a negative value, all the inequality signs are going to flip. So k is now going to be less than or equal to, let's see, 54 divided by negative 6 is negative 9, or k is greater than or equal to, if I take negative 38 divided by negative 6, I know it's not going to turn out perfectly, so as a fraction, that turns into 19/3. All right, we have officially solved it. All right, let's throw it on a number line, see what this thing looks like. So I need negative 9, I need 19 over 3. And because it's an OR graph, it actually doesn't matter. You're just going to look for any shading whatsoever. So k is less than or equal to negative 9, so from negative 9 I'm shading less than. K is greater than or equal to 19 over 3, I'm going to shade greater than. Both of these will take brackets. There's an equal to component. Slide this up a touch. So shading starts at negative infinity, stops at negative 9. Bracket here. And the shading picks back up at 19 over 3 to infinity. All right, we solved it, we graphed it, we put it on interval, wrote it in interval notation. So let's see, 5 and 6. All right, there's the final answers for page 1. Come on back for the video for page 2.